Very good evening, guys. Can you guys hear me and see me? Let me know in the chat. Very good evening, Arad. How you guys are doing? Doing good. Very nice, Arad. Very nice. So, are you guys practicing problems? Because from I think last two classes or before that, we were talking fully about problems. Today also we are going to talk about some of the problems in earlier classes. We discussed about stack and queues. Before that we were talking about heap. Correct, guys? So now in today's class we are going to talk about linked list. So I know linked list, we have already told that this is linked list is a little bit interesting topic because a lot of visualization is needed, and code written is also easy because whatever we are doing in the visualization, same code we need to do it on the like nothing extra we need to add there. Whatever we are doing in the visualization, same thing we need to do it in our uh, in the code as well. And I have seen the problems. All problems are easy actually, not very complex. I've seen all the problems which I'm going to talk about today. Okay, guys. So I'm hoping like Arad and Ekta, right now I can see you both. Very good evening, Ekta. And I know you guys are already practicing. So like Ekta in last class, Ekta has shared with us that she has solved more than 151 problems, and Arad nearby that, near to I think 40 or 60. So I'm sure like this count has been increased for you guys. Now it has to be, oh, that's nice, Ekta. So in one day you can see it's 154 for Ekta and 45 for Arad. That's great. That's great, guys. That's good progress. Actually, yes. If you will continue doing like four problems or four or five problem daily, even count it in the 1 month, how much more questions you are going to solve. Like this count will be near to 170 for you, Ekta, and I think for you also it would be 70 to 80, Arad. So you can see the small unit you will add it, and you will see a big pile of success in front of you. So I will suggest to everyone the same thing. Even Nishant has joined, so same to Nishant as well. Start solving two or three daily problems from the lead code. And I'm definitely saying, guys, that is worth it. Definitely, you guys are going to, like in any of the bigger organizations, definitely the people are going to ask question uh, uh, around these topics only: queue, stack, dynamic trees, graph. People are going to ask about questions around these topics. Kind of slow, but it's still doing daily. That's fine. That's fine. Slow is fine, but solving 3 to 4 problem daily, that is necessary. See the consistency. So Ekta has already said that consistency is the key. You are slow, that's fine, but you should be consistent. And there is difference. People is slow. People whoever is slow, they do 1 or 2 problems. Whoever is faster, they do 4 or 5 problems or 10 problems. But at the end, you will be reaching your destination after 2 or 3 days. That's all. Correct, Arat? You will be reaching your destination after 2 or 3 days, but you will definitely reach it. So that's why slow is fine, but consistency is necessary here. So yeah, I'm saying the same for everyone, not only for Ekta and Arad. Whoever has joined right now, Mayank has joined, Hariharan has joined, Vishal has joined. I'm like hoping you guys also start. If you have not started, if you're thinking like you have not already these people are so much ahead, and you guys are thinking about starting, please start it from today. After this class today, before sleeping, go and solve one easy problem, and then go for sleep. Okay, same for Suraj and Deepak. Whoever is continuously uh, joining the classes, same for Likhit as well. Whoever is continuously joining the classes, I'm suggesting to everyone, please start solving the problems. Practicing, Nishant is saying he's practicing topic wise. That's also very nice, Nishant. See, that will make your whatever topic you have just learned in the class, it will make concept more clear to you. So that's also nice. I think that's the best way. Whatever topic you guys just discuss here, go in the lead code, try out the find the try to find out the easy questions for them and try to start solving them. Trying to balance DSA plus development now. Okay, that's good. If you are able to balance it, definitely do that. If you are not, if somebody is not able to do the balance here between the DSA and development, so please right now focus on DSA first, because that's what we are daily talking about in the weekdays. But if Ekta is able to do the both, let her do that, and that's good, Ekta. If you are spending your time in both sides, definitely it will be good, like quick results for you. So Deepak is saying, so what do you think? How much time do we need to crack the interview? So Deepak, if you are fully prepared in the DSA and also have good understanding on the development side, I think you are good, right? You are done. Like you just need to revise all the concepts because you have already done the practice. So you just need one more week to just revise all the concepts, whatever you have taught, whatever you have learned, and then like after 1 week you can start sitting in the interviews and start seeing some patterns people are asking in the questions. Those things you can start seeing there. So I think after doing that, so I believe in 1 month, if you are already prepared and fully intentionally doing everything, I think in 1 month you should get the job. What I feel is reliable interview is difficult. I've not seen that the reliable interview, whatever you guys have done it. Not sure about that, Likit here. I have also not seen the reliable test which you guys are doing. Not sure about that as well. I think Reliable has good organized, good companies, right? Like Upgrade or no, not yeah. I think Anshul can answer that question. I'm not sure Anshul can also answer because there might be some people from the Reliable team only. They should come here and talk about these things because see, definitely there would be some Reliable, operators or the persons who will be continuously connecting with the companies, and they would be like assigning all the students to the to these companies. There would be some persons in the reliable as well, same like the colleges, right? In same colleges also we have one person who organize all these things, who has the understanding that how difficult these questions will this company will ask. It happens, right? Same would be happen in the reliable also. So we have reliable test practices last module, so we're learning there. Ah, yes. Hmm. That's right. In the test practice, might be somebody from the reliable who has nice past experience with the companies. He can join and he can share his experience, whatever he has with interviews. See, that is definitely needed because each organization has some specific interest when they choose when they choose their candidates, and that person who is continuously seeing these things, organizing all those things, so he definitely know these things. Same like the colleges. In colleges also happen when somebody specific company is coming like Infosys or Accenture or any like some new companies are coming. So the organization always knows that this particular company is going to focus on this area. So definitely it will happen on the Relbol also. I think you guys can chat with Ansul. I think Ansul is a very nice person. You guys should connect more with him. He might not able to give answers, but he will definitely connect you with the right persons. He always does for me. Whenever I have any queries, he always does for me. So I think you guys can connect to Ansul. He will definitely connect you with the right person. Okay. Okay, guys. So that's all about this, and I think now we have more people as well, and we have spent 7 minutes as well. So let's now, okay, now let's see two. Let's take two more questions and then we'll start. Okay. So Nishant is saying, for interview we should prepare for Node.js or DSA first. I think it would be great if you can go for them by like go for both in similar pace, because see in the Nishant, in the Node.js there's nothing to prepare, because if you have already implemented one application which was the e-commerce application, you just need to remember these things, because in the interview nobody is going to tell you that write the code, write the API right now. They will just ask you how you did it, how you did, how you have done the authentication, how you have created the models, what package you guys were using, and why you guys were using. So while people were asking about the Node.js, they why, what, how, these things question. They will be theoretically questions they will be asking you about. But when they will see see, this is all about the Node.js. That's what you need to prepare in the Node.js. But in the DSA, they will give you the questions which you need to solve it, which you need to write it. So always, I think you need to give more priority right now at the starting level. You have to give more priority to DSA because they would be because see in Node.js, if you are missing one or two questions, that's fine. That's fine. They will think like, okay, you have not worked on those. See, somebody is asking to you about sessions in Node.js. What sessions do? How sessions? How you implement the sessions? Why session is needed? See, why, how, and what? These things they will ask about the session. Correct? If you are not able to answer, you can see I have not worked, sir, on the session part. I was using something else for the authentication scenarios. So they will see, okay, that's fine. But that will not go in the DSA. If because in the DSA, I think they will only ask two problems or one problems to you. And if you're not able to solve it, they will clearly cut you out from the round. So that's why I think DSA in the starting stage, it's very important for you guys. But yes, as you increase your experience, like you go for 5 or 6 years experience, then answering the first question of session is also important. Otherwise, they will cut you out there as well because you do not have any knowledge about the thing which you are working from the last 5 years. So now I think it will make little bit clear, right, Nishan, for you? So I think right now you should keep the balance. Whenever you are talking about preparing Node.js, you just start whatever from wherever we started, and then start understanding about what, why, how, these things about the Node.js. Correct. When we are talking about the DSA, you have to practice it. You have to problem. You have to go to lead code. You have to solve the problems there. Those things you have to do. That's Nishan. Okay. English is important in interview. My English is weak. I will try to improve my English speaking English. Unfortunately, Suraj, yes, English is important in interview, and the reason for that is we are let's face the truth. Let's face the truth. We are uh, we are fully on the service based, right? We mostly do the service based things. So when we do the service based things, so we need to we always depend on the foreign people like the US or Europe, these type of people. So for interacting with them, we need to know English. That's why every interview in India, they are focusing on English. So definitely you need to spend some time. And see, there is nothing like you have to do the courses, anything. I have not done any courses till now, guys. I will tell you, I belong to Hindi medium as well. I have not done any of the courses, anything like that. In till 12th, like I was doing the simple sentence creations and whatever we have to do for passing the 12th exam or 10th exam in English. All the grammar on those things I did. After that, uh, when I joined my BTech in the first semester, I was very I was very sad because whatever teacher was teaching, I was not able to understand because that was totally in English, and some of the subject I was not able to understand, like the manufacturing. There was one subject in manufacturing I still remember. I was not able to understand because that was totally in English and they were totally theoretically, and a lot of new words was coming. I was like, I don't know what to do there. So I was not good. Like I didn't score, out of 20 I was scoring 6 out of 6 just because of language barrier. But after the next semester, now I started reading some of the I started went to library, try to understand the words because the grammar is still same. I'm saying like right now I'm saying, right, this is one in English sentence. So now you just need to know saying I, and just you need to start creating the sentence there. So somehow when I started reading when I went to the second semester, then at that time a lot of mathematical subject has come into that, thermodynamics or engineering drawing and mechanics. So all there was mostly the terms was there, the grammar was less, terms was like technical terms was there. So I was able to understand that. And slowly I think when you listen English for 6 months, In one semester, it means 6 months. Listening continuously 6 months, automatically your brain or your ear will started picking it out. That's why some people saying that watch English movies, because they also have some entertainment, and you are continuously listening those movies words, so you will definitely start understanding that. And the first English series which I watched, it was the Vampire Diaries. I was not full, I don't know the English. I took the because I was a little bit fascinated earlier about the vampires, so I just started watching that series. I was keeping my dictionary at the side, and I was continuously watching that series. So that's how you started. And then I joined the company in the IBM, the first company. There I the first time I was hearing to other organizations. See, when you are doing an interviews, the English in Indians, you can easily understand their English. Like you can easily understand my English as well. My English is not like as much fluent or anything like that. I'm just using very simple words, right? So till now it was good, but till I joined IBM, it was the Indian interview only. So English was good. Okay, that's fine. I can easily understand. But when I joined any organization like IBM, and there I was when I was trying to interact with the UK client or the US client, their English was totally different. I took, I think, 3 months to just to understand them, whatever like to understand their pronoun, whatever it's like volume they are talking about. Sometimes they are talking too quick, so it was very difficult for me to understand in three starting 3 months. But as I tell you, when you hear it continuously to them, you will start getting it. So that's what I did. So just start listening about being. I think reading newspaper would be boring. That's why people didn't do that. So that's why I start watching movies. That's entertaining as well, and you will continuously listening the English words as well, or web series. Okay, I think, guys, so we'll take the next questions like later, and let's start our topic. Otherwise, we will be diverted from there. Okay, we all covered the interview standard questions. So, what about the computer fundamentals? It's little bit necessary, but yeah, in the SD3 level, the computer fundamentals required there. Okay, yes, for soft skill. Oh, great! If you guys have, that's great. But we would not be having more of similar sessions. Reading newspaper would definitely help. So for Vishal, he's interested about the current affairs and geopoliticals. So reading newspaper is also helpful to know about that. Or if you guys are like interesting about, or do you guys have interest about history or geopolitics, politics? So there is one person, Abhijit Chabra, in YouTube. Abhijit Chabra is there. So he do very nice sessions in geopolitics and all in English, and very nice English you can understand. So you guys can watch it. Just for English, I am telling about. So I personally hear him. I just personally consider him as my guru, because I know he didn't know me, but I personally feel he has so much knowledge. If you guys just start seeing him, you will see that you will also might get feeling about that. So Abhijit Chabra is the person name. You guys can search about it. Okay, guys. So that's all about it. So let's jump into our today's topic. Yeah. So let's jump into. Let me share my screen. Okay, and if you guys have any questions, I'm like a lot of people are connecting to me in LinkedIn. I'm already answering their questions. Like recently, I remember the conversation with Nishant. He was also having some confusion on the resume part, so I answered him. Before that, I think I had conversation with Ekta where he was having some doubts. So yeah, so you guys can connect there, and we can talk about these things as well. I'm not sure, like I'm not saying like I will instantly give you answer. I can give you the later as well answer. But yeah, we can start. You guys, if you have any other questions, we can talk there as well. Okay, guys. So okay, so now let's start talking about today's topic, guys. It is linked list. Yeah, it would be great if you can send a sample resume. Uh, sure, I will invest some time. See, I will take some time for that, and might be next week. I will share in the not next week, because next week I'm fully traveling. After next week, after 3rd December. So I will share that. I will write this as a my point, and you somebody can remind me also if I forget it. So I will, after 3rd December, I will just try investing some time on finding out the good sample resume, and then I will put in the LinkedIn group about that, about the link, or might be directly the template of it. Okay, sure. I will try to find out. Okay. Okay, guys. So now let's talk about the link list. Okay. So, so let's start understanding about the linked list, right? So earlier, so anyone wants to explain why we jump into the linked list? Like earlier linked list, before linked list, we were using the arrays. Correct, guys? Everywhere we are, like whenever we want some data to store, we were using the arrays. So what was the problem which we were having with the arrays which linked list solved? So everyone answer it because we have already discussed about this. It's so I want everyone to answer it here. Meanwhile, I will reply. I will read the responses. So Likit says it has non-continuous memory. That's totally right because in array you know that after zeroth index, one index is coming. It means they are continuous. But in linked list, it's not like that. One node can be any other place. Second node can be in any other place. For connecting these two nodes, we use the next pointer. Correct? In the same node, we keep the address of next node. That's totally true. So yes, array has a static size problem which cannot be changed. For changing it, what we need to do? So if we want to increase the size of array or decrease the size of array, both things, not only increase, sometimes we need to decrease it as well. So for increasing, what we need to do? We need to take, first we have to like traverse whole array, one by one, take out all the elements from the array, and then create a new array which has increased size or decreased size and start putting into that. So that was the problem which we have with the static size. Okay. Non-linear data structure, linked list, non-linear data structure. Okay. Yes, because you are saying that it's not continuous. So that's why we can say it's not. But yes, is it non-linear? Okay. I'm just confused about that. Yeah, I think it's linear, right? It's still. Because see, linear mean, Hariharan, that in one direction we can go. See, when we talk about the non-linear, it was tree, right? Where we were jumping into the multiple dimensions, right? So I think linked list is the dynamic, sorry, the linear data structure. Okay, and yes, Likit and Vishal and Parag and everyone is also confirming it. So yes, Hariharan. So please correct that one. Whenever you think about the linear and non-linear, so you just think about the dimension, how many dimension you can travel. So in the linked list, you can travel in one dimension. In trees, you can travel in multiple dimensions. Okay. Dynamic memory. Okay. Suraj also understood that thing. Deletion is O of one. Deletion is O of one. Yes, that depends on if we have a tail there. That depends on when we have a tail there, right? When we have the tail pointer, at that time we can quickly delete it. And see, guys, we cannot generalize it. We cannot generalize the deletion because see, guys, if you guys remember, Vishal, just first telling to you that yeah, it depends on implementation, but still, deletion can always not be O of one because if you want to delete something from the middle, that's also you have to search that element. So deletion would be O of one from the tail or from the start point, right? Just visualize the linked list. Just visualize the linked list. Now think about if the element is at the last position and then you have the tail pointer, you can simply delete it in O of one because you can see O of one and O of n, they are only depending on it how quickly you can reach to that element, how quickly you can reach to that element. So if the element you want to delete from the last, you can quickly reach it with the help of tail pointer. That is O of one. Same goes for if the element you want to delete from the start pointer. So you can quickly reach it through the help of start pointer. Same goes for insertion as well, guys. Same goes for insertion. If you want to do the insertion on the right side and on the left side, like start and end, you can do it the O of one. Correct? But if you want to do in the middle, I think you need to reach that place. But yes, it also depends how you guys are implementing. Like if you remember LRU CAS, we were implementing very smartly in the LRU CAS. Every time coming at the last, something we were doing in the LRU CAS. That was very smart way to use the doubly linked list. Okay, now Vishal is saying I could have them connect keys in the map. Hmm. Yes. Now you are coming into the min heap. So that is not linked list now because you are coming into the min heap. Min heap or max heap or not the min heap, sorry. What was that? Hash table. Hash table, right, Vishal? Now we have come into the hash table where we can keep the keys at any object, and then we can reach quickly to the linked list or to the arrays as well. The arrays can also help there. Correct, Vishal? Okay, so that's what actually, guys. So now I think with this small discussion, I think you guys now like brought linked list into your cache memory, right? In your mind cache memory. Now you can think about like whatever the operations we have done, insert at the back, insert at the front, and sometimes we can do into the middle as well, right? Let's think about how many questions we have solved with the linked list. Anything, like anything which is coming into your mind as a first thing. That type of question I solved with the help of linked list. I see one thought is coming into my mind very quickly. That was fast and slow pointer. Where have we have used the fast and slow pointer? Anyone remember that one? Yes. So while solving the linked list problem, that was the first thing which is coming right now into my mind. Just thinking about it and just thought. What about you guys? Any other thing is coming into your mind other than that? Two times, okay. Mid of linked list. Mid of linked list. Yeah, for finding out the mid of linked list, we also use uh, that fast and slow pointer only, right? Finding the middle element, right? Yes, reversal linked list. Correct. Yes, reversal linked list. So in while we were trying to solve the reversal linked list, what anyone wants to quickly tell what was the logic which we were doing there? Because that's a very specific logic. Like that's also like very generic logic. While reversing a linked list, we have taken one previous pointer. We have taken one previous pointer, and every time, yes, and every time whenever we are traversing it, we are going into the next pointer and then keeping our previous pointer as well there. Yes, yes. So I just want to bring here the previous concept. Like in one linked list, we can have the previous concept as well. Correct? It helps us to solve some of the problems, right? So that was one of the concept. Previous concept was there. Then I think fast and slow concept was there. And what else is there? We first make the previous node point to next. Then we break the link from it, previous pointer, and node and reorder. Yeah, something like that. Yes. In the reverse, I remember we keep the previous pointer and then we start adding like we take the next point and then next of that we keep the previous pointer. I remember that logic about that one, odd one side and even one side. For that, what we did, Hariharan, odd one side, and yeah, I remember like from the odd indexes, we need to print the element and or all the odd indexes at one side or all the even indexes at one side. I think that type of question we did. Um, I think there also we use the similar these concept only. We find out the middle element, something like that, and then from the middle we done the reverse. These two these two concepts I think we have used there as well. Oh yes, finding out the cycle. Correct. Finding out the cycle. That was also one different topic. And I think we have solved the finding out cycle also with the help of fast and slow. Correct. With the fast and slow pointer, we have solved the cyclic problem as well. Right. Alternate nodes. Yes. So I think at the bigger level, I'm thinking like just the two or three concept, which yeah, I think two concept which is coming into right now in mind, which is the fast and slow, and second one is the reverse one. Those two strategies has helped us to solve a lot of problems. What do you guys say? Yeah. Okay, Vishal is saying when I didn't know about the reverse logic of O of n, I just used the advantage of prototype chaining. Hmm, prototype chaining. I still didn't get it. How do you are relating it? But we'll think. I will think about it and then later on we'll talk about it. Okay. So yes, actually, so I think we have mostly solved the problems, all of our problems, or difficult problems as well, with the help of fast and slow and the reverse one. Okay, let's see in the let's see quickly in our linked list one some problems where we can see something new as well. So merge sorted was there. Lot of problems actually. Yes, odd even list. Hmm. Yeah, I think this was the problem, like which was somebody saying odd and even positions. Oh, okay, yes. There we did head dot next. I remember, yeah, something like that we did. Reverse, okay, last front. Yeah, I'm happy. Like we have solved a lot of problems. Ah, okay. By creating one node from its prototype helped me. Ah, understood, understood. Got it, Vishal. You have just find out the JS loophole and just you started going back from there. Understood, understood. So yeah, actually, guys. So I think yes, we have solved a lot of interesting questions in linked list as well, which I feel some of them was hard, some of them was medium as well, right? So let's see today's question as well, and let's try to solve them as well. Those are, I feel, all of the questions which are mentioned in the today's slides. I feel those will come between easy and medium. Okay, and I think you guys will, and I think I'm expecting you guys also to give multiple answers to them. Okay, let's read the questions, and there are multiple answers to them. Okay, so let's read the questions and let's start solving today's problem as well. Okay, guys, so let's see our first problem. Okay, so the first problem it is, guys, nth node from the end of linked list. Okay, nth node from the end of linked list. So they have been given you one linked list and a number n. The number is n here. Your task is to find the nth node from the end of linked list. Your task is to find the nth node from the end of linked list. For example, if we have this linked list 1, 2, 3, 4, 5, 6, and value of n is 2, let me go to the one node and let's draw that. I think this question is like this. So we have this 1, 2, 3, 4, 5, and 6. This is our linked list. This will be pointing out to null. And this is head or a start. Anything you want to say here. Right, guys? And then we have one more n is equal to 2. And you need to tell me the node or node value from the end side, which exists at the nth position. So you can see nth value and the value of n is 2. So you need to tell from the last whatever the second element is. And in this case, you can see the second element is this one. So your answer would be 5. Correct? If somebody is saying n value is 5, what would be the answer, guys? If nth value is 5, what would be the answer? I will wait and I will then come back to chat. Okay, let's come back to chat now. So yes, everyone is saying two. Ekta is saying 5. I think that would be the older answer for us. Oh yeah, she has given 2 as well. Yes, so everyone is giving answer as a 2. That's right. So you can count it like that. See, 1, 2, 3, 4, and 5. Answer would be 2. Sorry, answer would be 2 here. Correct. So this is the question, guys. You need to find out the nth element from the end side. So what are the suggestions? What are the ideas coming into your mind? How to proceed for this? I think there is one idea which is very easy, which would come slow and fast model, which would help by having a difference of n minus 1. Bet them, beat them. Yes, definitely slow and fast is going to help us here. Definitely. Any other ideas which coming into your mind? Everyone, I'm sure definitely ideas would be coming into your mind, and you guys are writing right now. Count total nodes minus and traverse till one previous node. Yes, that's the another idea. You just count all the elements which are available in the linked list, and then differentiate it. Then differentiate it with the n value. Like there are 6 elements, right? So 6 minus 2 would be 4, and then just go to the fourth element, take the next element. Yeah, that's how. Okay, reverse logic may help. Reverse logic, yeah, if you do the reverse of it and then find out the second element. Yes, that's also right, Joseph. You just need to do the reverse and then you can just traverse it one more time to second element. That's also right. Okay, now Likit is saying take slow at 0 and fast at n minus 1. And while fast reaches end, we can return slow. Hmm. Take slow at 0. So, okay, so he's saying slow at the first like start pointer and fast at n minus 1. Fast at n minus 1 means 2 minus 1 would be 1. So at the first index, okay, it means the first element, first node. And while fast reaches end, we can return slow. Hmm. But Likit, there is one doubt here that how much how much jump you will take for fast. Are you going to take the jump only two step, or how are you deciding the jump for fast in your solution? In your solution, definitely we are going to solve with the slow and fast. But yeah, just answer me this question: how much jump are you deciding here? Because based on the jump, your answer will be reaching to slow. If we have double linked list, it would be much easier. Yes, definitely. Okay, guys. So definitely there are a lot of ways to solve these questions, and I like that two ideas, which is the fast and slow approach. N minus one steps from slow, slow plus plus, fast plus plus. Hmm. Okay. Hmm. See, let's start with the thought which Likit is suggesting to us. Let's see that will help us answer or not. Okay. So Likit is saying, let's take two pointers, which is slow and fast. Okay, and kept the slow at the first position, which is here, and then keep the fast pointer at n minus one position, which would be in this case 2 minus 1 is equal to 1. Correct? So yes, in this case, definitely it is going to help us. Definitely, the fast would be here. Then we'll move our fast. So once fast, like see, we can move it also. So let's move our slow to here next. Now, slow is here, right? Now our fast is here, right? In similar way, slow will be here, fast will be here. Then slow will be here, fast will be here. Then slow will be here, and fast will be here, right? And we can check that fast dot next is null, just return your slow. Correct? That could be the answer, right? But let's see, is it going to work for all the scenarios? Let's see if our n value is, um, if the n value is 5. Let's talk about if the value of n is 5. Correct? So let's see, we are again going to put our s pointer here, and fast pointer at n minus 1 would be at fourth. So fourth position to yeah, 0 1, we are considering this as a 0, right? So 0 1 2 3 4. Correct? So it should be here somewhere, right, guys? Wait, am I putting it in the right position? See, earlier when our value was n minus 2, sorry, n minus 1, so it was 2 minus 1 is equal to 1. So we put it here at the first index. So yes, when the n is equal to 4, so it would be 0, 1, 2, 3, 4. Now let's think, it will work for this one as well or not? So now let's move our slow pointer to here. Let's move our fast pointer to here. Oh yes, for this one also it is going to work. So that's right. Likit answer is also correct. So we just need to keep our fast pointer to n minus 1. We need another inner loop to move the fast pointer n minus 1 time. Yes, that would be the first loop. That would only be the first loop, Ekta. So for what we'll do, we'll first take the first pointer and move it to n minus 1 time. Correct? We'll move it to n minus 1 time. And then we will start our calculation from the same position. Slow will be at the... So, okay. So let's see, guys. Let's see how we are going to implement this logic. How we are going to implement this logic. Okay. So see, guys, let's take 2 pointers. So let's take 2 pointers. Everyone, yeah? Let's take slow pointer and fast pointer. Okay. Slow pointer will be here and your fast pointer will also be here. In starting, you will take the slow and fast, both would be pointing out to head. Correct? Now you need to move your fast pointer, or you can give it some other name as well, because it is, see, after some time, or yeah, fast is fine. Okay, fast is fine. So you just need to move your fast pointer to n minus 1 position. To n minus 1 position. Why we are saying n minus 1? Because we are starting from the 0. We are starting from the 0. Otherwise, if we can simply say till n position, if we are considering our loop to start from one position, like as a one value, we can say till n position also you can move your fast pointer. Otherwise, n minus 1 also. Whatever you want to say. That's not a point. Okay. So you just move your fast pointer to the n minus 1 position or n position, anything you want to say. Okay. That depends on your code, whatever you want to take. Okay. So now you can see in the case of where n value is 2, so you can see that you need to move your pointer to the second position. So this would be the position where you will move your pointer. Or if you are considering it as a n minus 1, it means this, you are considering this as a 0, 1, 2, 3, 4, 5. So then you can see n minus 1 is also going to be 1. So anything here. Now everyone okay with n minus 1 and n thing? Because it might confuse somebody. N minus 1 and n, it totally depends on how you are going to write your while logic, where you want to stop it. Everyone understood that part? We can take n minus 1 as well. We can take n as well. Sir, I have to leave the lecture now. My parents are forcing me to go to marriage of relative with them. Oh, that's fine. That's fine, Nishant. It's happening these days. I'm also going some like on Friday. So no problem. You can watch the recordings later. And if you stuck anywhere, you can ask to me in the LinkedIn. Yeah. Okay. So any like other questions, like Suraj is there, right? Suraj, Parag, Hariharan. You guys have understood that part, n minus 1 comma n part. That totally depends on from where we are starting. Okay, now we are good. So I'm taking right now n minus 1, okay? N minus 1. So now you can see our fast pointer has stopped here. Correct? Now what we'll do, guys, we will run another loop now. Not inner loop. It's a separate loop. Okay, Ekta was is talking about the inner loop. So now we'll run the another loop. And now that loop will run till we find fast dot next is not equal to null. Till we do not find dot next not equal to null. Okay, till there we will move now inside this while loop we will move our slow as well, slow dot next, and fast pointer as well. Why 1 position? Fast dot next. And now you will see, guys, we will be reaching at the correct position. So like you can see, now fast will move from here to this place. Slow will be here, right? Then fast will be here, slow will be here, then fast will be here, then slow will be here, then fast will be here, slow will be here. And now this while loop will stop because fast dot next is equal to null, equal to null. So now this while loop will stop and we will be returning our slow as our answer. Return slow as our answer. Everyone got this? So I think this is easy, right? This is easy. See, simple. If you just simply want to understand without these pointer and everything. So what are you doing? You are just taking 2 pointers and you have already moved. Like you just simply think about this as a race. You just simply think about the race. Like there are two person A and B. A and B. 1 minute. What happened? You just simply understand A and B both runs at the same speed. Both run at the same speed. Correct. So if the distance is 10 kilometer, so if you are keeping A 2 kilometer ahead, if you are keeping A 2 kilometer ahead, so definitely this one is going to reach earlier, right? 2 kilometer, like when the, like if you're starting B from here and A from here, so definitely B will reach earlier, and A will always be, because they both are running at the same speed. They both are running at the same speed, so definitely A always be 2 kilometer behind to B. A will always be behind. A will always be behind 2 kilometer. Like whatever gap you will maintain at the starting, whatever gap you will maintain at the starting, that gap will always be maintained till the end. And that's what our question was also asking. You need to find out the nth element from the backside. So the gap will always be maintained which you maintain from the starting, and always your A or your slow pointer will always be at the nth element or nth position. I hope now you guys have understood. Sir, why did n minus 1? Okay, because slow is at 0 and index start at 0. We need fast minus slow is equal to n. So Deepak, the reason is uh, okay, you're not asking about the n minus 1 and n. You are asking why did n minus 1. Okay, see, Deepak, for maintaining a gap. See, so what our question was asking, Deepak? Our question was asking that we need some element from the n side, from the last side, and that has to be distance of n. That has to be distance of n. Correct? So just simply understand, the two people are running and you want to find out at the destination where both people has to reach. From that destination, which is the person, or at what distance the last person would be, at what distance last person would be. So what you did, you, because they have given you the difference there. So what you did, it from the starting, when people are running, you just made the same difference. You just made the same difference, because you cannot measure it from the backside. You cannot measure it from the backside. So what you did, you when two people are running at the starting, you just made the same gap there. And now, because both people will be running at the same speed, so always the gap will be maintained. And when the first person will reach to the end, you will always see the second person. Whatever position the second person is there, that would be the nth value from the end. So that's why we are doing, for our fast pointer, that's why we are doing n minus 1 or n. Understood, Deepak? So just to maintain the same gap which we want at the end, and then we started running both at the same speed. Deepak, did you understood this part, or still you confused? Yes. Okay. So now, are we good, right, with that? Anyone has any doubt in the logic part? Hariharan, Suraj, Joseph, are we good with that? Okay. Let's see the code, guys. Let's see the code for this. I think we have similar code. Let's see. Yeah. Okay. So first thing, guys, we have taken a single linked list here because we need to create a linked list, right? So you guys can quickly see the linked list code as well. You can see for single linked list, we just need to create a node. Always the node has two things, data and next. By default, the node always point out to null. We already discussed all these things, and all one node always has, like in single linked list, node always has two things, data and next as their properties. So that's what the single linked list node is here. And then we have a single linked list class, which has prepend, append, insert at any position, or print list methods. These are some of the linked list methods. Okay. Then what we did, then we just initialize that class, that linked list, and then we prepend some of the values there. So this will look like 6, 5, 4, 3, 2, 1. 6 would be the no. It will look like 1, 2, 3, 4, 5, 6 because we are doing prepend. Guys, what would be the output here? If we are doing the between 61 to 66, what would be the output here? How our linked list will look like? Anyone wants to tell me in the chat? Yes, that's right. 1, 2, 3, 4, 5, 6. Correct, because we are doing the prepend. Now we'll see logic, guys. Now we'll see our logic here. The kth node from end. So like while I was explaining to you, I have taken the slow and fast pointer. So here I am taking first and second. I have given the name as a first and second. And you can see they both are starting from the head. Same like the fast and slow. Fast and slow was also starting from the head. First and second is also starting from the head. Now what I did, the next thing, I am looking for the n minus 1 position. Correct. So for that, I am just checking in my while loop, run this while loop when we have a first, when we have any value in the first, and kth value is greater than 0. Kth value is greater than 0. And then do the k minus minus. It's the same thing, guys. We are just, you can see, it's the same thing. Let me tell you why. See, the k value is 2. So this loop, this while loop, first will make the first will run for 1. It will do n minus minus. It will 1. Then one more time, and now it will become 0. So once it becomes 0, our loop will stop. Our loop will stop here. Where is the code? Yeah, our loop will stop, and then our first pointer would be at the same position where the fast pointer is. The first pointer would be the same position where the fast pointer would be at the n minus 1 position. And then at the end, you can see I'm just checking, like, because see guys, why I'm checking for first and not if first does not exist, return null, they might provide some value of k which is greater than the number of elements in the linked list. Like if somebody is providing the value of k to 8 here, if there somebody is providing the value of k as 8, so at that time first will become null. So that's why I'm checking here. If not first, simply return null, because we can't do that. And then if we find out any first which has any element, or fast pointer is pointing to any of the element, we'll simply do the fast.next, and at the end we are just simply returning the second. Okay guys, it's the same code. But yeah, you guys can tell me. I will just wait for some minute, and you guys can see here. And if you guys see anywhere any differences, let me know. Might be in the line number 79, you guys were thinking, while explaining the code, I was doing the first dot next. But why I'm doing here first? Correct. So this again, it will go into this part, k minus minus, where this k is stopping. Again, it will go into the k minus minus scenario, where this k is stopping. So do not like still, if you guys have any confusion, you can think in your mind where k is stopping, right? Based on that, the first will be first, you can see here. Now let me run it also. Let me run it. So now you can see in the same example, I'm asking for first element from the last first element. So let's see what is our output here. Node linked list node from last. So we are returning second, and it is giving us null. 1 minute. Let me console it the second here, guys. You see what is happening. One minute, guys. Huh? Am I running any other file? Because I can't see the second console as well. Oh, it is not reaching here. One minute. Let's print first and second here. Second should be head only at the start. First is coming as a undefined. Why is that? The value of k is 1 and it is greater than 0. So first it should be first dot next. Oh, it might be because of assignment is not happening properly here. The assignment was not happening properly, guys. That was the problem. 1 minute. Let me make it easy. Why we are doing it like this? Let's take those another variable, second as well. Okay. Assignment was not happening properly, guys. That's why. Yeah. Now it should work, I believe. You see, the return is, yeah, let's remove all these things. That assignment was a problem, guys. Let me write it there some console as an answer. Okay, now let's see. You see, answer is the last node, which is 6. Now let's look for second row, second element. You can see it is coming as a 5. Let's look for fifth element. Yeah, you can see data is coming as a 2. And that's what you can see. Our answer is also coming like that. For n is equal to 2, answer was 5. For n is equal to 5, answer was 2. Okay. Yes, first was not initialized. That's right. No, it was initialized, but the value was not, put it there. It was just initialized as a null or undefined. Yeah, yeah. I just corrected it. Vishal and Deepak. Thank you for pointing it out. So I hope everyone understood the code. Can we move into the next question, guys? You see, this is the code, easy one. Can we move into the next one now? Yeah, it was easy, right? Not tough. Let's know 73 line number. Okay. Suraj is saying about the 73 line number, which is this one. So yes, this is the first is equal to first dot next. So we, Suraj, we have to move to. So why not first dot next in while loop? Oh, okay. First, let me answer the 73 line number, Suraj. So Suraj, for moving our pointer to n minus 1 position, we need to move our fast, right? So that's why I was doing fast is equal to fast dot next. And fast, we are considering it as a first in our code. So that's why we are doing first is equal to first dot next. Because we want to move our first pointer or fast pointer to that position. That's why we are doing first is equal to first dot next. I hope you understood, Suraj, what is the purpose of that line. That's how we move it, right? That's how we move in our linked list when we do first equal to first dot next. That's what. So why not first dot next in while loop? Which line is talking about? First dot next in while loop. Oh, you are line number 79, Hariharan? Yes, say, I told you, right? The reason for that, Hariharan, the reason for that is we are using k minus minus. So see, If you will check for this code, k minus minus. So, okay, let me show you. So I think k minus minus, when we are looking for this while loop, it is what this while loop is checking. It has to stop when the kth value is greater than 0. So it means we are considering it as a first position. So let's do that. That's also fine. Let me show you that also, how that is working. But I thought you guys can think about it. But let's do that. Not a problem. Let's do that. Yeah. Hmm. So now let's think about, see, n is equal to 2 and our condition is k should be greater than 0. So yes, k is greater than 0. So fast to, let's move our fast to here. Let's move our fast to here. Then what we are doing? We are reducing our fast, k minus minus. Now it is k minus minus. Correct? So now k minus minus will make it 1. Our value of k will become 1. Correct, guys? It will again go into the loop. You can see it will again go into the loop because we are considering the kth value should be greater than 0. So now it will again go into the loop. And now our fast will be at this place. Now our fast will be at this place. Correct? Now the value of k will become 0. Now it will not go into this. So now guys, you can understand from here, now this fast has to go into to null, because you can see now we have two pointer differences here. So now this fast has to go to null. Otherwise, let me show you that also, no problem. Now let's move your slow and fast one by one. So your fast will be here, your slow will be here. Your fast will be here, your slow will be here. Correct? Your fast will be here, your slow will be here. Now your fast will become null and your slow will be here. Now that is your answer. So that's why you are not writing fast dot next is equal to null. You are simply writing when your fast become null, you have to stop it. So that's why I'm saying you, when I told you, I was sure that somebody might be confused about the line number 79. That's why I told you it totally depends on your kth value, how you are going to keep your loop here. If you make it k greater than 1, if you make it condition like this, k greater than 1, then I think you need to change this condition as well. Then it will be first dot next is not equal to null. Understood, Ariel? That totally depends on the value of k, how much gap you are taking it. I hope if others also has any doubt, they would also be clear now. Because earlier I just theoretically told you, but now it showed you as well. Yeah? Okay. So now let's jump into the next question, guys. I hope everyone is clear about it. Yeah? Okay. Now let's jump into the next question. Okay. So the next question is, guys, swap the pair. So write a JavaScript program to swap the consecutive nodes of singly linked list instead of data. So right now they are saying we do not need to swap the data. See, we are very smart people, right? We are very smart people. We can simply go to the next node and replace the data, right? We do not need to change the pointers. It would be very easy for us. But that's what they are saying. You do not need to change the data. You just need to change the pointers of them. You just need to change the whole node and you have to consecutively swap it. Let me show you what they want to say here. This is again the same linked list. 1, 2, 3, 4, 5, 6, and pointing out to null. So they are saying you have to consecute whatever the consecutive nodes are coming, you just need to swap them. So like this, these two nodes. These will be swapped to 2, 1. Then these two nodes 3, 4, 4, 3, sorry. 4, 3. Then these consecutive nodes 6, 5. And then null. That should be your answer, guys. That's what they are saying to you. You have to swap the pairs or swap the consecutive nodes. Correct. That's what they are saying in the question. Let me show you again. Yes, 2, 1, 4, 3, 6, 5. Swap the pairs here. They will be giving you the pairs there and you just need to swap those pairs. Have you understood the question? Yes, yes, Arad, you're you are going into the right direction. Previous and current pointer, you're totally going into the right condition. Because guys, this is not difficult questions. We do not need to think very much like advanced or extra here, because they are saying about the consecutive nodes or the pairs which we can easily track with the previous and current pointer. Am I right or not? Two nodes you can always track with previous and current. Can we or not? We can, right? We can. So we that's why we do not need to think a lot of things here. We can simply use our previous and current pointer. But yeah, there also we need to smartly use them. We need to smartly use them. Correct? We need to smartly use them, and then we can simply do this problem. Okay. Okay, so now Likit is saying temp is equal to current dot next. So temp is equal to current dot next. Okay. But yeah, something like that. Yes, the Likit is also going into the right direction. So let's guys quickly solve this question. And I think everyone can easily understand. We are going to use the previous and current pointer. And definitely in meanwhile, if you want to save some store, save some values, we can use the temp there. Correct? So let's see. Guys, so what we want to do, you can see, just observe this much. Just observe first these two entries. Okay, let's observe first these two entries. So now right now head is here, correct? Your head is here. So now you can see this head, we can make it as a current. So this is one pointer current, and our previous will be pointing out to null, correct? Because this one is the first element. So our previous would be pointing out to null. Am I right, guys? Let me write it here. Why do I write there? Previous would be pointing out to null right now, and current would be pointing out to this point. Right, guys? Till now we are good. We just created two pointers, previous and then and current. Correct. Now we start need to moving things. Now we need to start our nodes to move here. So see, guys, what we need to do first. We need to go for wherever current is right now. Wherever current is right now, we need to go for the next element. We need to go for the next element. You can see one is pointing out to 3. One is pointing out to see 2 is pointing out to 3. Correct. So later on we need this connection also, right? We need to make this connection to 1. We need to make this connection to 1, and 2 should be pointing out to 1. You can see in your output 2 should be pointing out to 1, and then 1 should be pointing out to remaining list. Correct, guys? 2 should be pointing out to 1, and remaining list of that should be pointing after 1. I'm not, see, till now we have not solved this problem, this remaining list. But for these two nodes, just for these two nodes, guys, just think about these two nodes first. Just for these two nodes, 2 should be pointing out to 1, you can see, and then 1 should be pointing out to remaining linked list. Am I right or not, guys? Everyone understood this thing? 2 should be pointing out to 1 means always the second element should be pointing out to first element, and then the first element should always point out to remaining list. Correct? So let's start doing that. Let's start doing that. So see, first take one pointer, which is going to be which is going to tell us the next value. So we can say write it like this. We can write it like this. Let next is equal to current dot next. Current dot next. Correct, guys? Which will give us node 2. Correct, guys? Which will give us the node 2. Am I right, guys? Which will give us the node 2. Correct. So now we have one, like we can, I will just write it as a pointer. So now here we have one pointer called next. Correct. So now we need to change this. We need to change this pointers next as well. Or we can write it as a next node. Next node. Now this next node should point to which node? Now this next node should point to which node? Node 1. Am I right, guys? This next node, yes, next node point to current node, to 1. Before that, we should also store the remaining list, which right now 2 is pointing out, which right now 2 is pointing out. Before before breaking this connection, guys, we should store it. So what we will do, let next to next, which would be next to next. Just write it here. Next to next is equal to next node dot next. I hope you guys are able to understand what I'm doing here. Next node dot next. Correct, guys? Now this whole remaining list, we have stored into this pointer, next to next. Now we can change this next node pointer. Correct, guys? Understood? Understood? Everyone? We need to first store the remaining list. Now we can change the current node pointer. So now what we'll do? Next node dot next equal to current node. Now 2 would be pointing out to 1. 2 would be pointing out to 1. Correct, guys? Now 2 would be pointing out to 1. Correct? Okay. Now just think about two things we need to do here. Now we need to think two things we need to do here. Now first we need to change our head as well. We need to change our head because head earlier was pointing out to 1. Now head has to point to 2. Head has to point to 2. Correct? Correct, guys? Our head has to point out to 2 because this is the first node. Joseph Matthews 3. What is 3? Where I have written 3? Yeah, what about 3, Joseph? That's the remaining list. That's the remaining list, which we have stored it into here, next to next. This in this pointer. That whole list is stored here, next to next. Yeah. So now, guys, what we'll do, we need to assign our head as well. But see, every time we do not need to assign head, because this is all running while loop. First it is checking for this pair, then it will check for this pair, then it will check for this pair. So that's why we need to put here some condition, and that condition would be if previous is equal to null. Because if previous is equal to null, then it means it's the head node. It means we are doing the first pair. If previous is equal to null, because we have not assigned anything in the previous, you can see previous is still pointing out to null. So if previous is equal to null, it means it's the head scenario. It's the head scenario. So what we'll do, guys, here, head is equal to next. Because you can see next node, sorry, hex is equal to next node. Head is equal to next node. Because next node, you can see, is still pointing out to 2. Next node is still pointing out to 2. So that's why we'll make our head to that. Now head will be pointing out to here. Head would be pointing out to here. And now, guys, we need to change one more thing. We need to change one more thing, which would be, see, we have not added this node. Or wait. Do we need to really add? I'm just thinking, do we need to really add anything here? 1 minute, guys. No, we don't need to add it. Just leave it like that. Just leave it like that. Okay. Now, guys, now we'll assign after this condition our previous node. Our previous node should be the next node only. No. Our previous node should be current node. Sorry. Yes, our previous node should be current node. Current node. Yeah, because you can see current node is 1. So now this should be our previous node. And current node should be the next to next. Next to next. Yes, I think yes. This would work. The current node would be next to next. You can see now current node will become this 3. This 3 will become current node, and this previous will become 1. And guys, did you guys understood these 2 lines first? These 2 lines are just for the next loop. These 2 lines are for the next loop. So what I did, I made my my current node. In this pair, my current node was 1. So I just made this as my previous node. Why? Because you can see this will come after 2. So this will be my previous node. And next to next, next to next, this should be my current node, because from here, now I need to take this pair. That's why I have taken it as a current to current node. Guys, last two line, everyone understood? Just to make our next loop. So where should we assign our previous and current? Which node we should assign our previous and current? So that's why we did. Sir, head is equal to next node. Yeah, head is equal to next node. I did it. Yeah. Yeah, we did it. See guys, now one condition is only leaving. Only one condition is left here. The name of variables. Name of variables. Head is equal to next node. Previous is equal to current. Is it not correct, guys? What's the problem here? I didn't understand like what is happening there. Got it. I'm using next node for different node. My bad. Oh, okay, no problem. Okay, guys. One condition is left only, guys. When previous is not null, because right now previous is, see, we need to add element into this, right? Whatever the next current element is coming, or next element is coming, next node, whatever the next node is coming, we need to add it here. So now, guys, we'll do here else. If previous is not null, we'll do here previous dot next is equal to next node. We need to add this next node somewhere, right? When previous is null, it means at those scenario head, it will be head will point to that. But if previous is not null, we need to add the three here, right? In the next loop, guys, 3 would be our current node, right? Sorry, 4 will be our next node. 3 will be current node, 4 will be our next node. Correct? You can see this code. In the next loop, next node would be 4. This would be a next node. So now we need to add this next node, right? So where we will add? After 1. That's why you can see this, then this will code will run in this flow. 2 will point out to 1, 1 will be point out to 4, 4 will be point out to 3. That's why we written this condition also. Previous dot next is equal to next node. Okay, now let me show you the code also. Similar code is written, guys. No change in the code. Same code is written there. Pair swap. You can see same code is written there. Okay. So you can see we have taken current node as a head, previous node as a null. Then I'm checking my condition. While current node or and current node dot next, any one of become null, because there could be even scenario or odd scenario. So for both of them, if current node or current dot next, anyone become null, then you can see first I'm taking the next node. You can see next node. I'm just keeping the name as a next. Then next to next, which is next dot next. Then I'm assigning next node dot next is equal to current node. Current node dot next is equal to next to next. Oh, by the way, I was not doing this thing. I was not doing this thing. I'm not sure this is needed or not. By the way, this is not needed. This line is not needed, guys. Line number 81 is not needed, because we are already assigning the current node at the end, and we have the previous node as well. So I'm sure this line is not needed. Without this line also, our answer will work. And then you can see if previous node exists, do the previous node dot next is equal to next node, same next node. And if doesn't exist, make it the head, ll dot head is equal to next. And then at the end, update your previous node, update your current node. That's why I'm saying this line is not needed. Then at the end, I'm just returning my print list after moving these things. Any line, guys, where you guys stuck? It was just simply moving our pointer here and there. And I'm sure if you guys have visualized it, like first tell me anywhere you guys face difficulty in visualization the code, visualizing the logic. Anyone, Suraj, Arad, because whatever visualization you guys have done it, same thing I have written in the code. Hariharan, Parag, anyone, Joseph. Okay, so no problems on the logic part. Now let me open the code for let's keep it for 1 or 2 minutes. Then let me know if you guys face any problem in that as well. Let me show you. Now you guys can see the code as well. Let me know if you guys face any problem with the code as well. I'm again telling line number 81 is not needed. No need to make current node dot next is equal to next to next. Already doing it. We are already doing it here. We are making our current node to next. Why we need this connection? I'm not sure. We can comment it out. This line not needed. But yeah, all remaining lines definitely needed. Okay. Are we good with the code, guys? Also, or do you guys have any line number where you guys is stuck? Any line number where you guys is stuck? Are we good? Can we move into the next one? Yes? Okay. Everyone, Joseph, everyone, okay. Hmm. So we are good, right? We can move into the next one now. Okay, so next question is, guys, intersection in linked list. Intersection in linked list. So what they're saying, they have given us two linked lists with unique nodes. Okay, and you need to write a program that take two lists and return the link with return the link list with the intersecting nodes. And the order of nodes in the intersection happening should be maintained as that of actual list one. So guys, what they're saying, they will be giving you two linked lists like this. Let me draw that here. 1, 4, sorry, 5, sorry. 1, 5, 8, 9, correct? Or 12 as well. And then it is pointing out to null. And then we have one more linked list, 1, 4, 5, 6, 7, 9, 10, and 12. And at the end, null. Yes. So now what they're saying, guys, they have given you two linked lists, L1 and L2, right? Now they are saying to you, they want a new linked list here, which should have only the like the intersection elements from these two linked lists, and the order should always be maintained. Correct. So like one, it is in both linked lists. Yes. So one would be the first node. Then 5, does it exist in both linked list? Oh yes, so 5 it exists. So order is same maintained. Same goes for 8. Does it exist in this linked list as well? No, it doesn't. So let's ignore it. What about the 9? Yes, it exists. So 9 would also become here. What about the 12? Yes, 12 exists. 12 will also come here. And then we will do the null here. So this was the question, guys. We need to find out the intersection node between the two linked lists, and then we need to return the final linked list with the intersection node. Did you guys understood this question? This question was easy, right? Just we need to find the intersection node between two linked lists. Okay, can you explain one more time? Okay, sure. Before that, okay, so it's like he's trying to explain the logic, but I will read the your logic, Likit. Let me explain the question one more time to Arad. Okay. So Arad, what is happening? They have given us two linked lists here. One linked list is this 1, comma 5, comma 8, comma 9, comma 12. And then second linked list is this 1, comma 4, comma 5, comma 6, comma 7, comma 9, comma 10, comma 12. And then in answer, they are saying that you need to find out the intersecting node or common nodes. Yes, the common node between these two linked lists. And then you need to return us third linked list, which would be having all the common nodes between these two linked lists. So you can see one is common in both linked lists. Yes, I created a new node of one in the new linked list. This is one. Then we have 5 common in both. Yes, we can see 5 is there. 9 is common, 9 is there. 8 was not there in both links. I have not taken the 8. Same for 12 as well. So I have taken that as well. That was all answer. So they want a third linked list. Got it now. Just okay, no problem. Okay. Now everyone understood the question. Now let's think about the answer. We'll use the pointers again. See, guys, I think they are telling here to create a new linked list. So no need to change anything in the existing linked list. So let's think in that way. We need to create a new linked list. So I think when they are saying no need to change the existing linked list, yeah, no need to change the existing linked list. We can create a new one. So then it question become very easy. Yes, very easy. That's right. So now let me read in meanwhile Likit questions as well. Likit suggestions as well. Take one pointer I in list one and another pointer j in list two. Iterate over list one while list one dot val is equal to list two dot val I plus plus and j plus plus. And if not equal, then I plus plus only until I is equal to null. And if I reaches a node, we have to create a connection between nodes. Hmm. So like Likhit is trying to suggest us if we have any existing nodes, if you want to change in the existing node, so what should be the way here? So I think yes, something like that we need to do here. So by the way, we'll talk about that as well. But before that, let's just try to create a new linked list here and go for that approach. I think yes, I know that's very easy. So what we need to do, guys, for the next approach, for the when we have to create a new node, we just need to start iterating. Just take the first node from here, try to find out if there is any node exists in the second linked list. If yes, create a new node in the linked list. Create a new node in the linked list. Same, go for 5. If that 5 exists in this linked list, go for 5 and add it into the third linked list. If 8 exists in this linked list, add it here. If not, just ignore it. Same for 9. If 9 exists in the linked list, add it into the linked list 3, and then same goes for 12 as well. Correct? That much easy. When we have to create a new linked list here. Yes? Yes, it would be n cross m because we need to traverse every time the new linked list. Correct, that's totally right. We need to do n cross m there. That's why we'll think about some other ways as well here. Okay, but yeah, before that, let me show you the solution for this, which is mentioned in the slides. So let me show you the solution here, guys, for this one as well. The intersection one. Yeah, let's see the solution here, guys. The easy one. So the same thing, we have created two linked lists here, having a third linked list for the results, and then you can see here what we did. We can simply yeah, this is simply addition of nodes in the first linked list. This is the addition of nodes in the second. Like this will all be given into the problem. When somebody will ask the questions to you, this all information will be given to you. Then this is our function get intersection, where we are seeing where we are passing two nodes, two linked lists here, L1, L2, and also passing a result linked list where we need to add the new element, the intersection element. So it's simple, right? What we have taken our head one into temp, then simply we just created one function is present, the second function, where we are passing our head to whole linked list of second, and then we are passing that but particular data, temp dot data like 1, then we pass 5, then we pass 8, then we pass 9, like that. And then in what we are doing in the is present, we are just simply checking if the temp dot data exists, simply return the true. If not exist, return false. Continuously move into this. And once we find it true here, let's create a new node and add it into our resultant list. That's what we are doing it here, guys. I know this one is very easy. Okay. See, for reducing a time complexity, Likit, we can do one more thing. We can take one, um, map here. just for the, yes, the map here, and then it would be come to O of n. Yes, then it will come to O of n. The time complexity would come to O of n. O of n or O of, yeah, O of n or O of m, anyone. O of m or O of n, anyone can come there. Which one is bigger, you can just keep it in the map and just take it here. Correct? That could go into the same for space as well. Code with map, okay. Anyone wants to create the code with map? That would be easy, right? So if anyone wants to create a code with map, okay, sure, Ekta, I will show the code. So please create the code with map and share in the LinkedIn. Okay, Joseph, so you can see in the LinkedIn. Sure, Ekta, let me show you the code. Guys, just see the code one more time. So we are calling the get intersection function and passing both of our linked list. And then we just pointed out one temp pointer there, and then we are checking, run this while loop till our temp become null. And then we have created one another function, internal function is present. In that function, we are passing whole linked list head to, and we are passing the current temp data, current node data as well. And then we are comparing it there. And you can see in this is present method, what is happening? We're just simply checking the data which we are passing from the linked list, first linked list. Does it the same value exist in the second linked list as well? If yes, exists, return true. Otherwise, return the false. Otherwise, return false. It's very easy, Ekta. Just simply finding out elements in array, similar like that. Okay, guys. And please also create the logic with map as well. And I will check in the LinkedIn whoever is followed, whoever will share that, whoever will share there, and I will tag. I think yeah, it will help to others as well, to Joseph and whoever else was looking for the map solution as well. Okay, guys. Anyone has any queries here? Any line number which you guys want me to explain here? Okay. In meanwhile, guys, let's think about any other ways we can solve it, like through the iterations. If the question would be to do it in the same, in the same existing linked list or in the linked list one. Let's think about that. How what could be the way to do that? As Likit was suggesting the idea. So let's see. So yes, I think see, we will be starting from the first linked list. We will be having one pointer here, the L1 pointer, I would say, and here would be having the L2 pointer. Correct? Then we need to start traversing. So L1, L2 matches. Wherever the value matches, we need to put one more pointer here actually, because whenever the next value will match, we need to put that value after L1. We need to put that value after L1. So see what we'll do, guys. Yeah, see guys, what we'll do, we'll stop L1 here. We'll not make our L1 move here. We'll make one pointer, keep it here, and yeah, I think we need to take two pointers, guys. We need to take one more pointer here to keep the next value, from the list and continuously traversing also. See, we need to do in one list, we need two pointers. In one pointer, we are going to traverse that list. And then from the another pointer, we are going to store the information. We are going to store the next information, whichever is which, whatever is the common We have to store it as well. Okay, we have to take max length list as a L1, two pointers in the L1 and one pointer in L2. Yes, one place definitely needed two pointers. Correct? If we are taking a two pointers in L1 only, let's take two pointers in L1. Okay? Let's think if that will work or we need to take in the L2. Let's think about it, which list we need to traverse fully. Yeah, I think we need to traverse fully the L2 one, the bigger length. Because you know why? Why bigger length linked list? Because there could be the last element in the see this 12 in the smaller linked list is traversing is it going it is lying into the last node in the bigger linked list. So that's why we need to fully traverse the bigger linked list. That's why we need to fully traverse the bigger linked list. So definitely we need to keep two pointers for linked list 2. Correct, guys? We need two pointers for linked list 2. So now let's see. Now let's start traversing our pointer. So you can see I'm just taking the two pointers just for storage. This is for storage where we are going to do storage, right? So earlier the both pointers are here. So L1 and L2 are matching. Okay. So keep our storage pointer here. Right now storage pointer is at this place. Now let's move our L2 and L1 both together. Okay. Now L1 at this place, L2 as well this place. Correct? Now let's see, is it matching? No, it's not matching. See, again we are confused. We should only move now L2, right? L1 should not be moved here. I think it's again going into the same way, right? It's again going into the same way. We need to traverse the whole linked list just for one node. Yeah. Okay, let's think about it later, guys. Then let's think about. I will also think about the other ways if we had in anything and share in the LinkedIn. Okay, guys. Okay, yeah. Let's go for break and let's in meanwhile think about it. Is there any other way? Yeah. Okay, guys. Let's go for break and then let's think. In meanwhile, I will also think if we can have some ideas here to do that. No way other than map. Oh yeah, Likit is confirmed now. There's no other way than the map to make our complexity better. But yeah, let's hope for best. We might have some ways. Okay, so let's go for break, guys, and let's come back at right now it's 9:36. So let's come back at 9:51, and then we'll see the further questions. Okay, guys, let's meet again at 9:51. 1 minute. I think I have started the charger, but I have not put it into the outlet. So is everyone back? Is everyone back? Let me know in the chat. Sarad is back. What about others? Back. Okay. Anyone's watching the World Cup in their dinner time? No? Nobody? I think Ankit was, or Vishal, who was that, who was talking about in the last class. Okay, that's fine. Okay, guys. So see, in meanwhile, I was also looking into the intersection part. So guys, in like I was looking about the Geeks for Geeks or anywhere. So we have solved one problem in earlier class where we need to tell the intersection point, right? From where two linked lists are merging. You remember that question, guys? We have two different linked lists. Those two linked lists are going to merge at some place, and we need to tell that link. We need to tell the merging point. That question was available everywhere, and that question has been asked everywhere. But this question is totally different. Cycle formation one, right? No, not the cycle formation one. There was one question, Likhit, like this. Let me show you. So like this, if you remember, like 3, 1, 5, and then we have some other linked list like 4, 6, and they both are merging to this point 1, or like anything 8, 9, and then null. So we need to tell the intersection point. This type of question. Yeah. So everywhere there I'm seeing like this question is mentioned, not the intersection one. Very difficult to find out the intersection point in internet. So in the lead code and everywhere, people are only talking about this question when I'm searching about the intersection one. So I think we have already done this one. So I think we are good till now, because this is the question which everyone is asking everywhere. Okay, guys. So now let's move into the next question, guys, which is the fourth question from today's class. Link list to BST. What is the properties which BST has, guys? Binary search tree. What is the property that BST has? Let me know in the chat. Anyone remember it? Left less than right, okay. Left should be less than root, and right should be greater than root. Yes, Likhit has totally put it correctly. Greater than equal to root. Left side smaller than root and root side greater than equal to root. Yes. So Likhit and Hariharan has given the proper answer. There's nothing mistake. But because in the BST, sometime for the duplicate elements, we kept them at the right side rather than on the left side. So yes, greater than and equal for the right side. Okay, guys. Yeah. So that was the properties for the BST. So now they are saying here in this question, they have given us sorted linked list. Very important, guys. They have given us a sorted linked list, and your task is to convert it into the balanced binary tree, or like you can say BST, keeping the time complexity as O of n. Note, in a balanced binary tree, the difference between height of left and right subtree is never greater than 1. So guys, the balanced binary tree. In the balanced binary tree, if you guys remember, There was two type of uh, like that was only tree, right? 1 minute, let me put open my diary. There was perfect binary tree or complete binary tree, right? That one we have, or absolute complete binary tree. We have discussed about these things, right? Absolute complete binary tree or perfect binary tree, correct? The perfect binary tree was when all the internal labels are fully filled, when all the internal labels are fully filled, and at the last label, every yeah, every node should be completely filled, right? That was the perfect binary tree. Let me see. I remember the diagram of perfect binary tree. That was like this, right? At last, let's see, all internal labels should be fully filled. I remember something like this. That was the perfect binary tree, guys. When we have all the labels filled, yeah, I think all the levels filled, that was the condition, right? And I think there was one absolute complete binary tree which we have discussed in later as well, which was all the internal labels are fine, all the internal labels should also be filled, but at the last label, at the last label, it should start from left to right, like this. At each node, it should fill left to right, like this. That was the absolute complete binary tree. Am I right, guys? Left mode filled first. Yes, leftmost filled first. So left to right. So for each node, it should fill from the left to right. So leftmost has to fill first. Correct. So here they are saying about the balanced binary tree. Okay. They are telling about the balanced binary tree, and they are telling also the definition of balanced binary tree, that the balanced binary tree is known as the difference between height of the left and right subtree is never greater than 1. So how we calculate the height, guys? Anyone remember how to calculate the height? Let's draw the height here. Let's take the same example, right? Okay. Yeah, let's take the same example. Why not? Let's just increase. Just I'm talking about the binary tree, not perfect binary tree, guys. Just about the binary tree I'm talking about. Okay. So let's talk about this thing. Okay. Yeah. So this is our left binary tree. You can see this is the left binary tree. Left binary tree. And this is a right binary tree. Right, right binary tree. So guys, tell me what would be the height for this node and what would be the height for this node. You guys tell me. So first tell me about this node. What would be the height here? What would be the height for this node, guys? Let's put this node as a, yeah, just I'm just pointing it out. Do not give any name here. Just about this node. What would be the height here? So yes, it would be the 1. It would be 1. So we have to see from the leaf node. We have to see from the leaf node how many edges are there. How many edges we are seeing from the leaf node, right? The maximum leaf node. So you can see here it's only the 1. So height would be 1 here. What about this particular node? What about, guys, this node? I'm putting it as a black. I'm putting it as a black. What would be the height here? For the black node, it would be 2, right? It would be 2. So now, guys, you can see here at each node, the maximum difference between left subtree and the right subtree should not be greater than 1. It should be 1 or 0. That's what the balanced binary tree definition is known as. If I increase one more node here, now you can see for this node, the height would be 3. Right, guys? Height would be 3. And now here you can see height is 1. So for this node, the difference between left subtree and right subtree is 2. So it is not balanced binary tree. It is not balanced binary tree. Minus 1 comma 0 comma 1. Hmm. No, no, no. I think 0 comma 1. Minus 1. Minus 1 will not come there, right? Minus 1 will not come. It would be absolute difference. It will be absolute difference. So 1 will only come there. If you're saying minus 1, it means at that scenario, you can do right minus left, right? So the left subtree or right subtree, it should be absolute difference. Okay, so it should be 0 and 1. If the so definition says it should not be greater than 1. It should not be greater than 1. Yes, we can take the absolute value as well. So wherever you see this scenario where the left subtree or right subtree, the difference between both subtree, if the difference between both subtree is not greater than 1, not greater than 1, we can say that that tree is also a balanced binary tree. That's what the definition says. Correct, guys? That's what the balanced binary tree definition says that. Have you understood about the balanced binary tree? Whatever we have learned till now, so just add this one also as an additional one. We have learned about, I think, a lot of binary trees, parts of binary tree, binary tree. Then we learn about the perfect binary tree, and then we learn about the absolute complete binary tree. There was one more, right? The first one. What was that? I'm just forgetting the name. I need to check the diary 1 minute. Yeah, the full binary tree. Yes, the the full binary tree was also there. Then the yeah, almost we have already covered. Then I think binary search tree. That was the next one. And then we also read about the binary heap. Correct. Okay, the partial one also we have learned about. Okay, partial one was also there. Mm-hmm. So yeah, so just all of them, just add one more property there. Whenever somebody says the balanced binary tree, you just need to remember the left subtree or the difference between left subtree and right subtree should be greater than 1. Are we good with that, guys? Are we good with that, guys? Understood the difference? What is the balanced binary tree scenario here? Okay, now let's think about this question. So they have given us one sorted array. Let's look into the sorted array. 5, 4, 1, 0, minus 3, minus 4, minus 5. So they are like giving it in the this order, decrementing order. We can take it in any order. Okay. So let's take it into increment order. Right, guys? So minus 5, mi minus 5, minus 4, minus 3, 0, 4, 7, and 8. 7, comma 8. Okay, guys. So, guys, I think once they said that it is sorted, once they say that it is sorted, I think it has already made our case very simple. It has already made our case very simple. Do you guys think that or not? Because we need to create a BST here. We have to create the binary search tree here. Right, guys? So when they are giving us the no, 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 no. In order is not sorted. In BST, it was in order was sorted. It was the pre-order, right? It was the pre-order, right? That was sorted. In order. It was in order. Okay. Hmm. left, right, root. Oh yes, left, root, right. So left will come there, and then root, and then right. Oh yes, yes, yes. You guys are right. Left, root, right. Yes, it was the in order. That's right. That's right, guys. That's totally right. Correct. So if somebody has given us, uh, yes, if somebody has given us a sorted array, just one thought is coming into my mind. Just let me think about it, guys. Oh yes, yes, that's right. That's right, guys. Yes, it was in order only. Yes. Okay, guys. So it was in order, right? So yeah. So if they have given us the sorted array, so now it has made very easy for us to create any tree, right? We need to find out the root, right? We need to find out the root, and all the left side of it would be all the smaller element on that would like see, because it's a sorted array. See, guys, this is the sort. This is the sorted array, right? This is the sorted array. So we just need to find out the middle element. We just need to find out the middle element, and after that, we know that the middle element will be a root element, and then we can simply say that all the remaining element into the left side would be going into the left side of it, left subtree. They will create the left subtree, and all the right side of it would be creating the right subtree, right subtree, right, guys? That's what our formula is: left, root, right, in order. Oh, sorry, this was right, right? My marker is, this is not working properly. That was the formula, right? Left, root, right, guys. So we just need to find the root, and then all the left side of it would be our left element, and all the right side of it would be our would be our yeah, all the right side of it would create the right subtree. Correct. So now, guys, we just need to do we just need to create our BST, and I think this is very easy question. We just need to take the middle element from here. We just need to take it because it's a sorted one. And the sorted one, always we just need to take the middle one of it. And now whatever the coming into the left side would create a left subtree. Whatever is coming into the right side of it would create the right subtree, as we are saying. So see, guys, once we will take the 0 as our middle element, you can see in this whole array, 3, 4, 5, 6, 7, 7 divided by 2, and we'll take the floor point. So it will give us 3. So 3 index would be 0. So 0 would be first root. 0 would be our first root. And then all the left element will look like this. Minus 5. What is happening? 1 minute. I'm not able to write anything. Minus 5, minus 1, minus 3 would go into the left side, and then from here mid to last element 4 comma 7 comma 8 would be our would go into the right side, guys. This is our left, this is our right. Again, this will be again a subtree for us. This will again a subtree for us. Same formula. Again, find out the middle element into this. That would be the minus 1. This would be our root. You can see this is our root minus 5. And then what we'll do here, like this, minus 5. Oh, by the way, we have written wrong here. It should be minus 3 in the here, because minus 3 is more smaller. Minus 3 should be here, and then minus 1 should be here, right? This is the sorted values. So now according to this value will also correct. Here minus 3 will come, and here minus 1 will come. So now you can see minus 3 will be here. The smaller to it would be minus 5, and greater to it would be minus 1. Same goes here as well. 7 would be a root element. 4 will go this side. and 8 will go at this side. Now they have only one element. We will simply, there is no left and right. Left and right are null. So no need to add anything here. Simply, these are the root element only. So into just add the null, just add the null. Same goes here as well. Same goes here. Same goes for this. Same goes for this. And add, need to return our root, which is 0. Which is 0. So we just need to find out the middle element, guys. And after finding out the middle element, just break our whole array into two parts. From a starting index till mid would be the left tree subtree. From mid till last, that would be the right subtree. And then continuously do the recursive logic there, and you at the end you will be finding out our BST. Okay, guys, that's how we are going to create our BST here. And see, guys, because this is linked list, so what we will do before that, we'll just simply run a loop into our linked list and push all the elements in an array. Push all the element in our array. So we can easily take elements out of array. We can easily take elements out of array and simply add it into a tree. Simply add it into a tree. Pre-order you have done now, sir. No. It's not pre-order, Joseph. I have told wrong there. It was in order. In BST, if you remember, in order is the one who gives us the sorted array. Sorted array. So in order, what is the in order, Joseph? It's the left root right, right? So root always be in the middle. So that's why what we did here, whatever total number of elements are there, we just went for the mid element and considered that mid element as the center element, the root element. Okay, now from the starting index till mid, we have taken it as a left subtree. From mid till last, we have taken it as a right subtree. So that's what you can see here, Joseph, in the code as well. This was our sorted array, -5, -3, -1. Then we have 0, 4, 7, 8. So our mid element was 0 here. So this would be our root. This one. This would be our root. Okay, I think I need to change my marker. Because see, sometimes I'm able to write it, sometimes I'm not able to write it. Okay, so guys, this is our root element. And now from the starting index, this is our starting index, right? Here. So from here till the root or till the mid element, this is also mid element, right? So till the mid element would be our left subtree. And from mid till the end, it would be our right subtree. And then when we got our left subtree, right subtree, same logic. Same logic we need to apply. Again, find out the mid element. So from starting index till mid would be our left subtree. And from mid till the right last index would be a right subtree. Same I did here as well. Everyone understood the logic here, guys? Can we move into the code now? Yeah, so let's move into the code. Code is also very easy. We just convert it into the array. I'm not sure if we have already done this question. I think no, we have not done it. Yeah. Yeah. So you can see from here, sorted linked list to BST, we are passing our linked list head. We are passing our linked list head. So what we are doing, we are converting that linked list to our array. We are converting that linked list to an array. So you can see here, guys, what I did, I passed my linked list to get array method. And now you can see simply in the get array method, I'm just checking if head exists. If head does not exist, simply return a null. If head exists, just take one like simply one array name of output and simply do the traversing into temp. And every time you can see temp is equal to temp.next. I'm pushing my all values to output array, output.push. The simple we are just simply returning our array. And then we're passing this array to our tree function. Okay, guys. So this was our get array function. Simply traverse the linked list and push all the elements to output array. Okay. So that was our get array. Now let's see what is happening in tree. So same process, whatever I told you there. Because our array are sorted, so it's very easy now. So in the array, you can see this is recursive function. So we are passing our array, the array which we got it from here. Start is by default 0, end is array's length. You can see end is as a array's length. And then I'm checking if start is less than equal to end, it means we have not traversed all the elements of arrays. So till then, just simply run that loop, find out the mid element. After finding out the mid element, make it as a tree node, the root node, that would be a root, and then start adding left and right subtree to that root node. You can see in the left node and the left subtree, I'm starting from start going till mid minus 1, going till mid minus 1, and then in my root dot right, I'm going mid plus 1 to end, and then continuously passing these values to tree. Continuously this loop will run. Whatever value this left subtree will return, I'm adding into the root dot left. Whatever value this will be returning, I'm returning return dot root. And at the leap scenario, when the leap will come, start will become greater than end. Start will become greater than end. At that scenario, I will be returning the null there. So in the leap scenario, root dot left will become null and root dot right will become null. So there it would be leap scenario. Okay, so now you can see I pass a left subtree as well, left node as well, right node as well, also considering the scenario for leaf node as well. But yeah, in meanwhile, let me stop here and you guys can see into this code and let me know if you guys is stuck somewhere in any of the line. We have seen these things many times, so I'm sure you guys won't be stuck anywhere. But yeah, still, if you guys stuck anywhere, let me know. Okay. Any line number, guys, or we are good here? Because see, guys, I believe we have already done all the all the good questions. So above, okay, all the good questions in linked list. So that's why now we have these easy questions here. Yeah. Okay. Yeah. This is Joseph, the get array function as well, where we are just converting our linked list to into our array. So we are simply just passing our head. We are checking if head exists, then go further. If not exists, simply return empty array. Then what we are doing is simply temp is equal to temp.next. So once temp become null, we'll stop it there. And before that, all the elements will be pushed into our output array. Correct? Then we're returning this output array and passing into the tree function. You can see the start position and end position. Finding out the mid element, creating the first mid element as a root for that subtree or for that tree, and then passing the left, then trying to find out the left subtree and right subtree. Any line number? Anyone is stuck? Are we good, guys, with this question? Yes? Can we move into the next one now? Hariharan, Suraj, Parag, are we good with this, guys? Okay. Suraj, I think he has not joined or might be. Okay. Let's look for the next question, guys, then. Same code is written here as well. You guys can later look into this one. Okay, now the next question or the last question is K reversing. K reversing. So you have been given a linked list. You need to reverse the node in linked list for every K group. For every K group. K is an integers which determine the group size. All the nodes in the group will be reversed. So now you can see, like guys, they have given us one linked list. One, two, three, 4, 5, 6, 7, and 8. And they have given one value of k, which is 3 in this case. Now they are saying whatever the value they have given, you need to create that group and you need to reverse the element into that group. Correct? So now in this scenario, if you will see that if the k value is 3, so this would be the first group. And you just need to reverse the element of it. So 3, 2, and 1. This is the first reversal. Now you need to look for next group. You need to reverse it again. 6, 5, and 4. Now you need to look for the remaining element because there is no 3 element. That's fine. You need to reverse them as well. 8 and 7. That is our answer. Let me compare it. 3, 2, 1, 6, 5, 4, 8, 7. 6, 5, 4, 8, 7. Yeah. First question is we need to look for the k element, like a group of k element, and we need to reverse those elements, not the kth element earlier. Do not confuse this with the kth element. In the first question where we were looking for the nth element from the last, that was nth element, nth position. But here it's not like that. It's a different question. It is saying that you have a group of k element, and in that group of lk element you need to reverse all those elements and then create a linked list here. Did you guys understood, guys, this question? Yes, everyone understood? So guys, what do you think about this question? See, this is very similar to the okay, so Ekta is saying like 1 2 3 4 5 0 2. So do 2 1 4 3 6 5. Yes, 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 Ekta, that's right. So see, we have very similar question, right? The swap of pair, yeah, swap of pair. That was also very similar to that. Yes, but there we have the consecutive element. We have to just simply reverse the consecutive element. But here, the k size could be anything. Yes, here k is variable. That's why that logic will not work here. But let's see, Vishal has given one suggestion. We could separate every group of size k, reverse the group, and then join them. Okay. Yes, why not? We can just reverse it. And yes, actually, that's right. You just go till kth element, right? And yeah, I think yes, that definitely, I think Vishal, that could be one way to solve this problem. Yes, we just need to take like some extra pointers, and then it will work. It will definitely work. Instead of dealing with pointers, we can definitely change values. Yes. That's also one way to do that because they are saying it here. They are not saying it here that you should not change the values. That's also is possible here. You can simply like go till kth element and see. But yeah, changing value. Okay, yeah, like it. That's also nice way. But tell me, can we do it in like so? Yeah, what would be your way to change the values? Because there could be multiple nodes, right? So there is 3 nodes right now, or there could be 5 nodes as well at one time. So how will you change the values? How will you know that which index has to which value has to go which index? Any idea about that? Yeah, this is question for everyone. If we are going to change the values also, how are we going to understand which value to change it now? Or just think about, guys, if we are going to create a new linked list, if we are going to create a new linked list, yeah. So what about that way? If we just think in the similar way, I think Likit ideas and creating a new linked list is going to be same way. Okay. So now tell me, guys, if we are going to create a new linked list, how are we going to decide which value to take it here? Which value to take at first position, which value to take at second position, which value to take at third position, or if the kth value is 4, which value to take at fourth position. Okay, so Likit is saying I at start and j will go to kth node, and then while I less than j we can do swap. Oh, okay, so you are just swapping I plus plus comma j minus 1. Okay. Hmm. What about any data structure we can use? Any data structure would help us? Oh yeah, stack. What the other things? Okay, stack also. Why do you guys think stack can help us? Reverse order. LIFO. Last one. Yes, that's what the key here. Last in, first out. Yes. Definitely stack is going to help us to achieve the same thing which Likit was doing through the loop. Correct, guys, or not? What about you guys think? Hariharan, Vishal, or Suraj, Arad, what do you guys think? Stack will definitely help us, right? So what we'll do, how we'll start solving this problem with stack? We will first insert k element in stack. From our linked list, we'll first traverse our linked list till k element, and we will insert it into our stack. Yes, we take first k element in the stack, then after that we'll start popping it out. We'll start popping it out, all these three elements, and then add add them in the new node, add them into the new node, add them into new node, or swap it as the like it was saying, we can swap the values as well. So we can swap the values there, and then we can add the remaining k element again into the stack and go for that, and again try to add it. Same logic can work there. Yes, it is. Rather than going through the loop, stack could help us here. Let me show you in the code as well, guys. That's what the code we have also written for solving out the same problem. You can see here the k reversing through the through the stack. You see, we are using the stack for pointing out the kth element, right, guys? And see here, what we are doing, we can create a new element as well. Otherwise, if we do not want to create a new element, guys, okay, we have not talked about this thing. Yeah, if we do not want to create a new element, we can still do. We can still see see what will happen. We can start a new head from there. We can start a new head from there. We can take a previous or head. Okay, okay, yeah. Let's talk about this also. If we do not want to create a new element, still I think, see, guys, it will be same, like it will be same. It will be same like create a new element only, right? It will be same like creating a new element. Even if we see, even if we want to start our head from a new position, it would be still same, right? See, in this case, 1 comma 2 comma 3 will start from the new head only. Same head, we can do that also, this dot head, right? It will still start from here. So, okay, that's fine. Let's do that. So this is a stack, and our k element is there are three. The value of k is 3, so 3 element will be pushed into a stack: 1, comma 2, comma 3. Am I right, guys? This would be 3 element would be pushed in the stack. Correct? Now we'll run one loop. Now we'll run one loop. And that loop will run while temp stack, or simply we can say head is not null. Head is not equal to null. Correct? Or we can not head. We can take this head into one other variable, like we can say current. We can take it into the current as well. And then we can just simply check for if current is not equal to null. Okay. One minute, guys. My marker actually is not working properly. 1 minute. Not able to write anything properly. See, I'm scratching. Okay. Okay. So now what we'll do, guys, we'll first take top element from the stack, and we'll take one 2 pointers as well for tracking out our previous, because after one we need to add the next three. After one we need to add the next three. So that's why we have to create the first as well, right? So see, guys. So the current element would be our current element would be our first node. Current element would be our first node, which we have taken out from the stack. So this would be our current element. This would be our current element. And we'll take it as a 3. So we'll take it as a 3. So 3 is there. Now what we'll do? Now we'll take the second element from here. And we'll consider, we'll also write it here. If previous is equal to null, if previous is equal to null, we'll add it into this dot. See, my marker is not properly working, so I'm not. Let me show you guys. 1 minute. You can see here, if previous is equal to null, you can see, guys, this is okay. Let's start from here, guys. So this is the first line of code where what we are doing, we have just simply inserted all the 3 elements into our stack. You can see temp stack dot push current, and current is equal to current dot next and count plus plus. Correct? We have inserted all the elements into our stack. Then what we are doing, we are just running a second loop while temp stack dot length greater than 0, because now we have inserted 3 elements in the temp stack. Then what we are doing, we are checking for if previous is equal to null. Just take the top element from the temp stack and put it into the previous, and make it that previous as our head. Make it that previous as our head. Otherwise, if previous is not null, like 3 is already been added, now we need to add 2. So it means previous will have some data. So now what I'm doing, previous dot next is equal to temp stack dot pop. So the next element which is present in the temp stack, we'll take it out, and then we'll create the previous dot next. Once the temp stack become empty, again go upside, push the next 3 element, and then do the same thing again for the temp stack. And at the end, once everything is done, once your previous come at the last element, make previous dot next is equal to null. Make the previous dot next is equal to null. Let me try it again, guys. Let me try a new page. Somehow I'm not able to write it anything here. Let me try a new page. 1, see, 2, 3, 4, 5, 6, 7, 8. Okay, and this is our null. And value of k is 3. Okay, so guys, what I did, I have taken a stack here, taken a name is that a temp stack. So what is the first thing which I did? I just pushed all these 3 elements into our stack. So 1, 2, and 3. Now when I pushed starting k element, what I'm going to do next, I'm just going to run another loop for our stack. So what I'm going to do here, guys, so before that I have already taken 2 pointers, previous, which is pointing out to null, and current, which is pointing out to our head, which is pointing out to our head. Okay, or simply do not need current pointer, we can take head as well, but that's fine, let's take it. Okay, now in the while loop, what I'm doing, I just taken out the first element of out of our stack, which is 3, which is 3. So now this is going to be our first element, guys, right? So we need to make this element as a head as well. We need to make this element a head as well, because this is the first element which is coming out of the stack. So what I'm going to do, what condition I applied? If previous is equal to null. If you remember, this is the same condition I applied for the consecutive scenario as well. If previous is equal to null, if previous is equal to null, make this the popped element. I'm saving it in temp. Make this as our head. So what I'm doing, head is equal to temp element. Head is equal to temp element. Else, if this is not the case, if means previous already pointing to some element, right? It means previous is already pointing out to some element. So then what we need to do? Previous dot next is equal to temp element. Previous dot next is equal to temp element. And at the end, whatever the next element is coming, make it as a temp. So temp is equal to previous is equal to temp. Correct? So after 3, 2 will come. So you can see previous dot next is equal to temp, and now this will become our temp. This will become our previous. Correct? Then 1 will come out, then this will become our previous. Now previous is here. Head is headed at this position. That's why I'm saying, guys, we are creating a new linked list. Right? Now there is nothing in the stack. Guys, there is nothing in the stack. Now we are going for the next 3 element again for these 3, 4, 5, 6. So now 4 will be inserted, 5 will be inserted, and 6 will be inserted. Again, same thing happened. But right now, previous is not null. Previous already has something. So previous dot next is equal to temp. So 6 will be added here. Then 5 will be added. Then 4 will be added. Similar way with this code. Now again our stack is empty. Now again our stack is empty. Now we'll again go for the next 3 element, which is 7, 8. We do not have 3 element. So first we'll insert 7, then we'll insert 8. Now 8 will be coming out here, then 7. Now you can see 7 will still waiting for any element. We need to make it null. Otherwise, you can see in the original code 7, because we are not creating a new linked list here. We are already using the existing linked list. So that's why 7 will be still pointing out to 8. So we need to make this 7 to null. We need to make this 7 to null. That's why, guys, you can see at the last line, at the line number 74, we are doing previous dot next is equal to null. Previous dot next is equal to null. Guys, let me show you again the code. You can see this is our temp stack. This is our current pointer which I'm talking about, and this is our previous pointer. I'm continuously running this loop till my current become null. Till my current become null. It means all the element we will traverse it here. Then what we are doing, the insertion part in the stack. So till our current is not equal to null and then count is less than k, you can see I'm starting my count as 0. Till my count is less than k, simply push all the element in a temp stack and move our current pointer to the next pointer and then do the count plus plus. So count will also increase. So after inserting 3 element, we will stop, we'll come out of this while loop. And then we'll go for the temp stack one. Go for the temp stack one. And here we are checking. This will run only first. Previous is equal to null, it will only run for first time where we will be looking for head pointer. You can see there, this dot head is equal to previous. And then next time we'll go for else part. Exists, so we'll do next is equal to temp stack dot pop. And then we are doing previous, we will do previous dot next. So it means we are assigning the previous values like the temp stack values, whatever this value is coming from the stack to the previous pointer. See, we are not writing it again because we are not storing that temp stack value anywhere. So that's why what I did, previous is equal to previous dot next, smartly going to the next element only. And at the end, previous dot next is equal to null. Understood, guys? I think this was easy, right? We just need to insert element in the stack and then traverse it through the stack and then print it out, like print it out or insert in the new one or add into the existing one. Same thing is going to happen in the whole scenarios. Anyone? Can you show the code? Sure, sure. This is the code 8 term. We are passing our linked list here, the value of k, or we can pass the linked list also here. Right now we are passing k here only, and we are taking this dot head as our current element, previous as null. Then we are running our while loop, and this loop will only end when current will point out to null. Means all the element has been traversed. Then what we are doing? Count is equal to 0. This is part where we are inserting our element in the temp stack. You can see every time we are just inserting the whole node. You can see inserting the whole node, not the values, inserting whole node. And then we are doing current equal to current dot next, count plus plus. Once this count will become equal to k, it will be stopped here. It will be stopped here. Then once all the elements has been pushed to temp stack, we'll just simply checking, just simply popping out all the elements from the temp stack. So after popping it out, we are checking if previous equal to null. It means it's the first node in the linked list because we do not have any previous. So that's what I did. What I did in the previous, I assigned that node, taking it out of the temp stack, and then this dot head is equal to previous. So now previous is also got updated, and this dot head also got updated with same values. Both have same values. Same goes for else scenario. When previous, we have a previous. It means it's not the head scenario now. We have the previous. So previous dot next is equal to temp stack dot pop. So we have taken that element, and now we are moving our previous to next element. So whatever the next element will come, we can add after this new element. So that's why previous equal to previous dot next. At the end, we have when we have already added everything, and that previous element will definitely pointing out to something else because we are using the existing nodes. So previous element will definitely pointing out to next one. So with that, at the end, we did previous dot next is equal to null, and I've shown you this example here. You can see at the end, and once 7 is coming, because the 7 will coming, but we are using the existing node, 7 will be definitely pointing out to 8. That's why it should not point out to this. So that's what I did. What I did, the this would be previous will be here. It will be waiting for next element, but now there is no next element. That's why we got the null here. That's why we have to put the null here. So that's why the last line is doing that part. Previous dot next is equal to null. I hope now this code makes sense to everyone. Joseph, Fariaran, Suraj, now this code makes sense. Ekta, Vishal has already said yes. What about others? Yes, Joseph says yes. Hariharan also says yes, understood. Okay, so that was, I think, the last question, guys, from our linked list slide. We are done with the linked list. I think all the questions was today was like easy, I would say easy to medium. The last one was little bit interesting, I would say. Otherwise, all the previous 4 questions does not have any like the medium level or hard level complexities here. What do you guys say? The last question, a little bit, we can say that it's interesting. But before that, I think, yes, it was all too easy to medium. Yeah, we can say that. But yes, tomorrow's question definitely is going to be interested. Sort the triplet, sir. Sort the triplet. Uh, in this question you are talking about, Hariharan? There is a question. Okay, sort a triplet. Do you see it in my list? Let me know which one you're talking about. I'm coming back to now chat. First one, the circular linked list. Okay, we have anything sorted triplet here. Let me come back to, I think you were saying something else. In class deck. Oh, in the class deck, okay. Sort the triplet. Oh, okay. You guys have some different content. Oh, I'm not aware of that question, guys. Can you guys like share that question on LinkedIn? I could look into that one. Yeah. And I will check like if you guys have any different content there. Tomorrow on heaps. No, I think tomorrow we are going to solve sorting problems. I have seen that tomorrow we are going to solve some sorting problems. So we're going to see some stack or sorting strategies. Thank you for sharing this. I will look into this question, triplet one, Hariharan. And then I think tomorrow, if we have, tomorrow I think we can talk about this question. Yeah, it has our first question. We can talk about this one. As it was about linked list, it might have been appended later. Yeah, might be possible. So no problem, guys. I will look into that question, and tomorrow class, we could first start with that question and quickly finish it, and then we can jump into the next one. Okay, guys? Yeah. So I think that's all, guys, from today's class. Stack permutation problem. Stack permutation problem. Yes, I remember that problem was the popping, and we can do the multiple ways to pop it. Yes, we have that problem, right? Stack permutation. Let me quickly show you the code. Stack permutation was there, right? Arrange collision. Where I moved this problem? It should be here, right? We moved it somewhere else. Stack permutation problem. I am in the master branch. Oh, guys, I have not shared the code for stack permutation. I have not shared the code for stack permutation, guys, because I'm not able to see it in the repo. So, Joseph, no, I think. Oh, okay. Thank you for reminding it. So, you want the code or you want to understand the logic for that, Joseph? And the question has got permutation for its name, it seems. So, Joseph, you want the logic for that, or you have already understood the logic? Wants the code only? Because I can see stack permutation code is not here, right? Or we have written in somewhere else. Stack to. Let me check quickly. That's fine, guys. I will add it. I will add it. Yeah. So the stack permutation was, Joseph, like if we have one array, if we have one stack with some elements, so how many ways we can pop out the element from the stack? how many possibilities are there for the stack permutation. Okay, and I think I already explained in the LinkedIn the reason for the reasoning which I got, because in the stack permutation we remember we were seeing one problem when we were not able to delete it. In the description it was saying that we should not be deleting it, deleting the element from the output. I remember I had that code. How can I miss that code? Not sure where that code went. Min deletion, min digit. Hmm. Interesting. By the way, yeah. So in that question, I didn't find anywhere the reason why people are not look in the problems. You should look for it. Yeah, I already shared that. Let me check in the problems as well. Might be I've added in a trees or what. No, I don't know. We'll see later. Or it was queue. Oh yeah, it was in the queue, guys. Right? It was, yeah, it was in the queue. It starts from stack, but the question was in the queue, right? Yeah. So yeah, code is here. So yeah, so so I think the question where we stuck, that was why we are deleting from the output queue, right, guys? So somebody was saying, when I was reading the others' opinion about it, so they were saying like while implementing, you can consider that output that is not a queue. You can consider that output is not a queue. It is an array. You can consider it as a. You can consider that as an array, and from the array you are simply checking it. You are simply checking. You are using that array as simply checking your answer from the input queue is correct or not. So in one way they are saying you're not using that output queue as a you're not using that output array as a queue for you. So that's why you're not deleting anything from there. You're just simply you whatever answer it's coming, you're just simply inserting into that one. So you're using that output array just for checking your answer. That's what people are saying everywhere about it. And I think yes, that makes sense. Without checking the answer, how can you compare it that your whatever you are popping it out, it is correct or not? See, if you have 2 3 5 and in a stack, without knowing you want two first or three, how can you pop something, right, guys? For stack permutation, you definitely need something in output. Then only you can tell that stack permutation can happen here or not, or is it the possible combination of stack permutation or not. So that's what people are also saying, that the second array which they have provided is just for checking your answer. Not Do not consider it as an output queue. That's what people are saying, and I think that makes sense. Without getting a second array, we were not able to identify that whatever the question is asking. If somebody is saying to you, you just need to create multiple stack permutation. I think there is one question where they will be giving you one stack, they will be asking you, you just create multiple stack permutation for it. I think in those scenarios, you do not need to delete anything from your output queue. If some question is there like that, sure, Hariharan, I will push it. Joseph, you got it? What, why we are, or anyone has any doubt there? Let me add it into the first this into the master one. Yeah, I put it. What about you guys, Joseph? Others, what do you guys think about it? The opinion which I shared about the last stack permutation questions, or also in the LinkedIn, I was expecting some responses there, but you guys have not responded there. What do you guys think right now? What about others? Vishal, Hariharan, Likhit, Ekta, Arad, Suraj. What do you guys think? Vishal is there. Because it took me 3 to 4 times right, and but it is clear now. It is expected on lead code the same code. Oh yes, that's right. But yeah, I think the opinion which I had, I think that makes sense, right? No, no, Vishal, that's fine. You, if you're not connected, I just explained you the reason, right? What do you think about that explanation? Does it make sense to you, or does it make sense to others? What about others? Hariharan also says yes. So yeah, I think that makes sense to me also, because without no, because I feel it, without knowing the output array, we were not able to tell that this output array. See, no need to delete it. You can simply use the if there is an array, you can simply use the pointer as well. No need to delete it. Do not consider it as the second array, as in the queue, as a queue. Do not consider it as. You can simply use the pointer approach there as well for the second array. Not allowing the dequeue from output queue, we can use a pointer, then increment it once we have a match. Yes, that's also right. It means we will not consider it as a queue. Just simple as that. The output one will not consider as a queue. We will not consider as the output queue the same one they are putting in the description. The output queue they are talking in the description, that's not the same. The output array they have provided, that's not the same. Okay, guys. So that's all I had for that question as well. And I think Joseph, yes, that code is already there. You can find it in the queue folder. Okay, Joseph. So that's all, guys, from today. Tomorrow we'll again meet at the same time, and we will be talking about some more questions in the sorting. I think there we have some interesting question in the sorting. Yeah, those are also easy questions, but some interesting there. So we'll solve those questions tomorrow. And on Sunday, you guys have break. I don't know if you guys have any other session, but I'm not going to take the Friday class. And then we will going to talk again on the Saturday. Oh, you guys have test on Sunday. Okay, test on Sunday. Okay. So all the best for your test, guys. Yeah. So let's. Two classes left. I think three classes, right? Monday we also have a class one. So I think sorting, searching, I think two topics are that. And I think there you guys will aware of it, right? Two topic or one topic, 1 minute. Let me check. How many topics are there? 1 minute. Yeah, Ekta is also saying three. So yes, we have three topics, I think. Yeah. Okay, guys. So let's wrap it the class today. We'll meet tomorrow as well. Yeah. And after tomorrow, actually, yes, Friday morning I have to travel, so I have to backpack in afternoon tomorrow. So I can just simply after the tomorrow's class go for sleep and then go next day to Delhi. Yes, that's right. Hariharan, see, now he's talking in the linked list way. Very nice, Hariharan. Yeah. Thanks, guys. Have a good sleep. Bye bye. Good night. We'll talk soon. And when wherever you guys have stuck, post in the LinkedIn. I'm already answering all the queries there. Okay, guys. Bye bye.